Before farming, before cities, and long before written maps, Ice Age people were already crossing dangerous open seas. They reached islands that had never been connected to the mainland using fragile boats made from wood reeds and fibre. Some voyages led to new continents, others ended without a trace beneath the waves. So how did these ancient sailors navigate beyond the horizon, and what evidence did they leave behind? Before we go deeper, like the video and subscribe for more forgotten mysteries of the human past. The sea is in the wrong place. Where waves now break against cliffs, there are plains. Where fishing boats cross deep blue water rivers, wander through grasslands crowded with animals. The English Channel is not a channel at all. The Persian Gulf is a broad low basin crossed by freshwater streams. Much of the shallow sea around Southeast Asia has withdrawn, joining lands that modern maps divide into separate countries. Australia and New Guinea belong to one vast continent, although even this greater landmass remains separated from Asia by a chain of deep channels. Along coast after coast, the familiar outline of the world has been erased and redrawn. This is the planet of the Ice Age sailors, but the first mystery is not how they crossed the water. It is how much of their world the water later destroyed. More than 20,000 years ago, immense ice sheets lock a portion of the planet's water onto the continents. Their white surfaces stretch across much of northern Europe and North America, in places rising to heights that would dwarf modern mountains. The oceans respond by falling. At the coldest stage of the last glacial cycle, global sea level stands roughly 120 meters below its modern position, though the exact local shoreline varies because the crust bends beneath the weight of ice, and because gravitational and regional effects make sea level change uneven. A number such as 120 meters sounds abstract until it is translated into landscape. It means that many continental shelves now hidden beneath shallow seas lie open to wind and sunlight. It means valleys where there are bays, marshes where there are straits and coastlines, tens or even hundreds of kilometers beyond their present positions. The familiar world becomes only the high ground of a much larger one. People do not experience this as a map changing all at once. No hunter wakes to find an ocean missing. The transformation unfolds across generations woven into ordinary life. A family follows reindeer along a river whose mouth lies far beyond the modern coast. Another group camps beside a freshwater lagoon on land that will eventually become seabed. Children learn the position of spring's shellfish. Bed stone outcrops and sheltered coves. Elders carry stories about routes inherited from people already dead. The coastline may shift slowly enough to appear permanent within a lifetime, yet over centuries it moves with enormous consequence. A beach becomes a dune field, a river cuts a new channel, a marsh expands across a low valley. The places most useful to human beings remain close to the boundary between land and water, precisely where later flooding will be most destructive to the archaeological record. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. Because the story hidden beneath these drowned landscapes changes something fundamental about the human past. Archaeology is often imagined as a science of ruins fixed firmly in the earth, stone walls, caves, graves, hearths, and broken tools waiting beneath layers of soil. Yet for most of human existence, sea levels have frequently stood below their present position. Vast areas available to prehistoric populations are now underwater, and the surviving record is therefore tilted toward uplands, caves, and inland sites. The apparent emptiness of ancient coasts may not mean that people avoided them. It may mean that the evidence lies beneath sediment, surf, and shipping lanes. This imbalance matters because coastlines are unusually generous environments. They compress different sources of food into narrow zones. Fish move through estuaries. Shellfish gather in tidal flats. Birds nest on cliffs and islands. Seals haul out on beaches. Rivers bring drinking water and attract terrestrial animals. Driftwood arrives without anyone having to cut a tree. Reeds provide fibers, bedding and material for baskets or mats. Exposed rock may offer stone suitable for tools, while sheltered inlets provide places where small craft can be launched or pulled ashore. Coastal living is not necessarily easy. Storms, salt, dangerous tides, and sudden shortages can be severe, but a productive shore can support repeated visits and detailed knowledge. It can also encourage people to look outward. The Ice Age coast is rarely a simple line. It is a broad, restless frontier of lagoons, mudflats, dunes, islands, river mouths, and wetlands. The distance between landmasses changes as sea level falls, but not everywhere in the same way. Shallow seas disappear, first creating enormous plains and joining territories that are separate today. Deep channels remain. Some islands become hills on a continental landscape. Others grow larger but stay isolated, surrounded by water too deep to drain, even during the coldest periods. From the perspective of people moving through this world, the difference is crucial. One route may become a walk across open grassland. Another still ends at a shore with land visible on the horizon or hidden beyond it. Lower seas simplify certain journeys while preserving the danger of others. Southeast Asia provides one of the most dramatic examples. The shallow Sunda Shelf emerges, connecting much of mainland Southeast Asia with Sumatra, Java and Borneo in a single extended region, often called Sundaland. Rivers cross this immense exposed plain, and forests and grasslands shift with changing rainfall. Yet east of Sunderland, the seafloor drops into deep basins and trenches. Here around the island zone known as Wallacea, water continues to divide the land. Even at maximum glacial lowering, no continuous bridge joins Asia to the continent formed by Australia and New Guinea. The geography creates a world of enlarged islands and narrowed passages, but still a world in which certain movements require leaving the ground behind. Rapid sea level rise after the glacial maximum later transforms this region again, fragmenting plains, moving populations and drowning many of the landscapes across which earlier communities lived. Far to the west, the same global process produces different worlds. Britain is attached to continental Europe across the broad plain now beneath the southern North Sea. Herds, rivers and human groups move through terrain later remembered by archaeology under the convenient name Doggerland, though it is never a single unchanging country. In the Mediterranean, lower water expands coastal plains and alters the shapes and distances of islands, but deep basins ensure that many islands remain islands. In the Persian Gulf, exposed land may contain river valleys, wetlands and freshwater refuges. Around Africa, Arabia, India, and the Americas coastal plains extend outward, shifting possible migration routes and hiding early camps far from the beaches visible today. Every region has its own pattern, because the shape of the seabed controls what falling water reveals. The landscapes are not static even while the ice remains. Climate pulses between colder and milder intervals. Rainfall belts move. Forests advance or retreat. Dust crosses continents. Rivers change course as glaciers grow, melt or redirect drainage. In some places, lower sea level creates rich plains. In others, colder and drier conditions make exposed territory harsh. The phrase Ice Age can suggest one endless winter, but the Pleistocene is a long sequence of climatic oscillations. Human communities live through local combinations of wind vegetation, freshwater prey and coastline. A land bridge on a map may be ecologically difficult to cross. An island passage may be dangerous but lead toward abundant resources. Geography offers possibilities, not instructions. Then the ice begins to lose its hold. Meltwater returns to the oceans, sometimes gradually and sometimes in faster pulses. Shorelines creep inland. Low valleys flood and become estuaries. Hills become islands. Freshwater marshes turn brackish, then marine. Campsites disappear beneath tidal flats. Stone tools are scattered, buried, rolled by waves, or sealed below sediment. Organic materials decay unless trapped in exceptional conditions. Wood fibre, hide cordage, and light watercraft almost always vanish. Even stone artifacts may be difficult to locate across areas measured in thousands of square kilometres. Modern underwater archaeology can map ancient river channels, recover isolated objects, and occasionally find preserved structures. But the scale of the lost terrain is immense. What has been discovered is likely only a fraction of what once existed beneath the North Sea and other drowned shelves. This creates a peculiar silence. The most direct evidence for coastal adaptation and early voyaging may have occupied the exact zone most thoroughly erased by post-glacial flooding. Archaeologists are left with fragments on surviving islands, tools carried inland animal remains, geological reconstructions and traces found by chance in nets, dredges, quarries, or seabed surveys. Scholars still debate how strongly this missing record distorts the story, and no single reconstruction can restore every vanished estuary or camp. Coastlines do not simply move. Waves rework them, sediment buries them, and tectonic movement alters their position. The evidence remains incomplete because the landscape itself has become an archaeological filter. Yet the sea did not erase everything. Some islands stood beyond the exposed shelves. Some passages remained open even when the oceans were at their lowest. On those islands, stone tools, butchered bones, hearths, and other traces survive are above modern water. They form a scattered chain of clues across different regions and different ages. Each clue carries the same unsettling implication. Lower sea levels can explain many ancient movements, but not all of them. Somewhere along these lost coasts, people reached the edge of the land, studied the water, and found that the road continued only if they could build something that floated. That final step from shoreline to water was once treated as a late invention. For much of the 20th century, many archaeologists assumed that true seafaring belonged to the age of farmers' villages, polished stone tools, and permanent trade. Boats in this older picture appeared when societies became settled enough to build them, organised enough to crew them, and wealthy enough to exchange goods across distance. Hunter-gatherers might have followed rivers or paddled along sheltered coasts, but open water crossings were often imagined as rare accidents rather than deliberate achievements. The idea seemed reasonable because boats are difficult to find in the archaeological record. Wood rots, fibre decays, shorelines drown. A vanished technology leaves behind only the places it made reachable. The geography, however, refuses to cooperate with the old assumption. Some islands contain evidence of human presence from periods when no land bridge connected them to a continent. The channels separating these islands were not shallow plains waiting to emerge during a glacial low stand. They were deep water barriers carved by tectonic forces and preserved even when sea level fell by more than 100 meters. To reach the other side, people had to float. The craft may have been simple, the journey short by modern standards, and the destination sometimes visible from the point of departure, but none of that changes the essential fact. Human beings left solid ground and crossed water that could not be walked. This distinction is easy to lose when ancient maps are reconstructed. Lowering sea level makes the Ice Age world look crowded with bridges. Britain joins Europe, Borneo, Sumatra and Java merge with the Asian mainland. Australia and New Guinea form a single continent. Yet the exposed shelves can create an illusion that nearly every migration was terrestrial. In reality, deep channels remain between some of these greater landmasses. Certain islands are reduced in distance from their neighbours, but they never cease being islands. A journey may shrink from 100 kilometres to 20 or 30, yet 20 kilometres of open sea is still a profound obstacle for people without engines, metal fastenings, weather forecasts, or written charts. Visibility matters, but it does not eliminate risk. On a clear day, a high island can sometimes be seen across surprisingly long distances. Clouds gathering over unseen land may also reveal a destination beyond the horizon. Birds flying at dawn or returning at dusk can suggest direction. Even so, a visible shore can be unreachable. When currents run across the intended route, winds push a craft sideways, or rough water overwhelms a lightly built vessel. Distance on a map is not the same as difficulty at sea. A narrow strait may be more dangerous than a wider passage if water is funneled through it with greater speed. The first people to attempt these crossings do not need to understand oceanography in scientific terms. They need experience. They must know how a floating structure behaves under weight, how quickly weather changes, which materials remain buoyant, and how many people or supplies can be carried before stability is lost. They need some means of propulsion, even if it is only a shaped branch used as a paddle. They must choose a departure point, read the surface of the water, and decide whether the conditions are acceptable. Perhaps some journeys are unplanned, made after storms tear people from a coast or carry fishermen away. But accidental drift cannot easily explain every repeated occupation, transported stone, or successful movement involving enough individuals to establish a lasting population. This is where the evidence becomes more demanding. A single object on an island can be misdated or moved by natural processes. A small collection may represent one brief visit, but repeated layers of occupation tools made from local material food remains hearths, and patterns of settlement begin to imply sustained knowledge. If people return to an island, they must remember how to reach it. If raw materials move between islands, someone is crossing in one direction and possibly returning in the other. If a population survives for generations, the first arrival likely includes more than one exhausted castaway. No single clue proves a fleet of skilled navigators, yet the clues accumulate until pure accident becomes less convincing. The surprise is not simply that hunter-gatherers could build boats. It is that the intellectual demands of voyaging fit naturally within a mobile way of life. People who move across large territories already carry detailed mental maps. They track seasonal resources, animal behavior, water sources, weather, and the timing of plant growth. They preserve root knowledge through teaching and shared memory. At sea, the landmarks change, but the underlying skill remains familiar. Observe patterns, remember them, and pass them on. A coastline becomes another path, and an island becomes another known place within a wider landscape. Still, scholars debate how intentional the earliest crossings were. The evidence rarely preserves the moment of departure, the form of the vessel, or the motives of the travellers. Some islands may have been reached by small groups swept off course. Others may have been explored during short foraging trips before any permanent settlement followed. The record does not allow every voyage to be reconstructed with confidence. What survives suggests a spectrum ranging from mishap to planned migration, not one universal model. What can no longer be defended is the belief that meaningful seafaring waited for agriculture. Farming began at different times in different regions, mostly within the last 12,000 years. Some island crossings are far older. They belong to worlds of stone tools, mobile camps, hunted animals, gathered plants, and coastlines now submerged. The sailors who made them did not leave harbours, shipyards, or written accounts. They left only their presence on the far side of water. That presence forces a change in perspective. The earliest boats were not primitive rehearsals for later civilizations. They were solutions created by people facing immediate landscapes, a reef visible offshore, smoke rising from another island, birds returning from beyond the horizon, or a dark ridge standing across a channel. The sea was dangerous, but it was not an absolute boundary. Once that is understood, the scattered islands east of the Asian mainland begin to look less like the edge of the habitable world and more like a training ground for one of humanity's oldest forms of exploration. East of the exposed plains of Sunderland, the land breaks apart. The broad Ice Age continent formed from mainland Southeast Asia, Sumatra, Java, and Borneo ends not at one clean frontier, but in a confusion of islands, channels, volcanic ridges, reefs, and deep blue water. This is Wallacea, a region that remains divided from both Asia to the west and the greater continent of Sahul to the east, even when global sea levels fall to their lowest point. The islands grow larger during glacial periods, and some passages become narrower, but the seabed between them is often too deep to emerge. Anyone moving through this world must cross water again and again. There is no single bridge, no hidden corridor of dry land, and no route that allows human travellers to keep their feet on the ground all the way from Asia toward Australia. The name Wallacea comes from Alfred Russel. Wallace, the 19th century naturalist who noticed that animal life changed sharply across parts of the Indonesian archipelago. On one side lived many species associated with Asia, including monkeys and large placental mammals. On the other appeared creatures with affinities to Australia and New Guinea. The boundary was not perfect, because birds, bats, insects, and plants could cross more easily than large land animals, but the pattern revealed something important about the sea. Deep channels had separated these islands for immense spans of geological time. Even during the coldest phases of the Ice Age, elephants could not simply walk from one side to the other, neither could people. For prehistoric travellers, Wallacea was not one obstacle but a sequence of decisions. A group might reach the eastern edge of a large island and see another dark shape across the water. After crossing, they would still face another channel beyond it. Some islands offered freshwater-sheltered bays, edible plants, shellfish, pigs, birds, or stones suitable for tools. Others were dry, steep, and difficult to inhabit. A successful voyage therefore required more than reaching land. The travellers had to survive once they arrived, understand unfamiliar resources, and perhaps continue toward another shore. Every crossing extended the map held in human memory, but every island also created the possibility of becoming trapped. The route through Wallacea was never fixed. Sea levels rose and fell, coastlines shifted, and volcanic activity repeatedly altered local landscapes. Some passages that seem obvious on a modern map may not have been the easiest prehistoric routes. Currents between the Pacific and Indian Oceans move through the Indonesian archipelago with considerable force, especially where water is squeezed through narrow channels. Seasonal winds reverse direction. Reefs can protect a coast from large waves, but can also tear open a lightly built craft. A voyage of only a few kilometers may demand careful timing, while a longer crossing with favorable currents may be completed more safely. What survives in the record suggests that people learned to navigate this broken world surprisingly early. Archaeological sites on several Wallacean islands preserve stone tools, animal remains, shell deposits, and traces of human activity stretching deep into the Pleistocene. The record is uneven. Tropical heat, acidic soil erosion, volcanic deposits, and rising seas destroy or hide evidence. Many of the most useful coastal camps are probably submerged, while caves and rock shelters survive because they stand above later shorelines. This creates another distortion. Archaeologists often find people inland in caves, even when much of their daily life may have unfolded closer to the sea. On islands such as Sulawesi, evidence points to a long and complex human presence. Stone artifacts from very early deposits suggest that an unknown human population may have reached the island before modern humans appeared there, although the identity of these toolmakers remains uncertain. Later Homo sapiens left clearer signs, including cave art hunting evidence and tools adapted to local conditions. Sulawesi itself is enormous and strangely shaped, with long peninsulas separated by mountain ranges and gulfs. Reaching it does not end the maritime challenge. Moving around it can involve coastal travel and further crossings, encouraging communities to remain attentive to the sea even after settlement. Farther east islands such as Timor Alor and the Moluccas form stepping stones towards Sahel, but the word stepping stone can make the process sound easier than it was. The stones are separated by deep water, and some destinations may not have been visible from low departure beaches. Travellers may have climbed hills to search for cloud patterns or distant land. They may have watched the paths of birds, floating vegetation, and smoke from natural fires or human camps. They may also have launched without certainty, guided by expectation rather than sight. The evidence remains incomplete, and scholars still debate which route was used. First, how many crossings were involved and whether movement occurred in one sustained expansion or through repeated episodes over generations. The people making these journeys were not moving through an empty environment. Wallacea contained animals found nowhere else, including dwarf proboscideans, giant rats, unusual reptiles, and island birds. Isolation produced strange evolutionary outcomes. Large animals sometimes became smaller because resources were limited, while small animals could grow unusually large in the absence of familiar predators. For arriving humans, these creatures would have made each island feel both recognizable and alien. Some could be hunted, others may have been dangerous, difficult to catch, or unfamiliar enough to require new strategies. Fishing and shell gathering offered more predictable food in some areas, but coastal resources also change with tides and seasons. Repeated crossings probably transform social life as well. Knowledge of routes, weatherboat construction, and landing places would have been valuable. Certain individuals may have become especially skilled at reading currents or shaping timber, though archaeology cannot reveal their names or status. Preparing a voyage required cooperation. A craft had to be built or maintained food, and water-gathered children protected and departure timed. Even a small group needed trust. Once communities were divided among islands, marriage partners, tools, stories, and useful materials may have moved across the same channels, turning water into a connection rather than a barrier. Wallacea therefore becomes more than a corridor on the way to somewhere else. It is a maritime world in its own right, one that trains human populations to think in chains of islands rather than continuous continents. The travellers who enter it cannot know the full geography ahead. They discover it piece by piece, shore by shore, carrying only what can fit on a fragile craft. Yet somewhere beyond the eastern islands lies a landmass of extraordinary scale. Reaching it will require one final series of crossings, and when people succeed, they will complete one of the most consequential migrations in human history. Beyond Wallacea, the eastern horizon holds something larger than any island yet encountered. Australia and New Guinea are not separate lands during the Ice Age. Lower sea levels join them with the exposed floor of the Arafura Sea and the broad lowlands of the Gulf of Carpentaria, creating the vast continent now called Sahel. It stretches from tropical forests in the north to cold southern plains, from dry interior basins to mountain ranges where glaciers cling to the highest peaks. Yet Sahel remains isolated from the Asian world. No matter how far the oceans retreat, deep channels still guard its western approaches. Reaching it requires a maritime crossing, and the people who make that crossing enter a continent no human population has occupied before. The exact route remains uncertain because the ancient shorelines lie beneath modern seas and because Wallacea offers several possible pathways. One broad possibility leads through Sulawesi and the Moluccan Islands toward New Guinea. Another moves farther south through Flores and Timor toward northwestern Australia. Neither route is a simple straight line. Both require a sequence of crossings, and the final passages include distances substantial enough to demand preparation. Some destinations may have been visible from elevated ground under clear conditions. Others may have been hidden beyond the horizon, detectable only through clouds, bird smoke, drifting vegetation, or accumulated knowledge about the direction of land. Archaeological and genetic evidence indicates that modern humans reached Sahel at least around 50,000 years ago, and possibly earlier, although scholars still debate the oldest proposed dates. Dating the first arrival is difficult because the earliest camps may have been brief coastal and later drowned. Inland sites record people only after they had already crossed the sea and moved into the continent. A stone tool or hearth found hundreds of kilometers from the ancient shoreline proves that humans were present by a certain time, but not exactly when the first boat touched land. The earliest chapter remains compressed between uncertain dates and missing coasts. Even the most cautious chronology makes the achievement extraordinary. These travellers possess no sailcloth, metal blade compass, or written map. Their craft must be made from organic material that leaves almost no trace. Bamboo rafts are possible in some regions because bundles of large hollow stems provide natural buoyancy. Log rafts, dugout vessels, or platforms supported by timber may also have been used. Fire can hollow and shape wood when suitable tools are limited. Vines and plant fibers can bind sections together. The boats may have looked crude by later standards, but a vessel does not need elegance to cross a channel. It needs to float under load, survive waves, and respond well enough to paddling or steering. The passengers matter as much as the craft. A lasting population cannot easily be created by one or two accidental survivors. Genetic continuity suggests that the settlement of Sahul involved enough people to establish communities, although the number of founding voyages is unknown. Researchers have used demographic models to explore how many individuals might be required to avoid immediate extinction, and while estimates vary, the general implication is clear. The colonization probably involved multiple people, repeated crossings, or both. Women, men, and children may have traveled together. Water food tools, fire-making materials, and perhaps useful plants or animals had to be carried. This was not necessarily a grand expedition assembled by a centralized society, but neither does it resemble a lone castaway drifting helplessly into history. A journey towards Sahul may have begun without any understanding of the continent's scale. From the first landing place, the newcomers would see only a coast, perhaps mangroves, beaches, rocky headlands, or tropical woodland. Beyond it lay environments unlike those of the islands they had left. Sahul contained giant marsupials, enormous flightless birds, large reptiles, unfamiliar plants, and landscapes governed by highly variable rainfall. Some animals had no previous experience of human hunters, others were powerful enough to be dangerous. The settlers had to learn which plants were edible where fresh water persisted through dry seasons, how fire moved through local vegetation, and how prey responded to pursuit. The speed with which people spread across Sahul suggests remarkable adaptability. Within a relatively short period, in geological terms, humans reached very different parts of the continent. They occupied tropical northlands, arid interiors, cool southeastern regions, and the highlands of New Guinea. This movement does not mean the continent was crossed in one uninterrupted rush. Populations likely expanded along rivers, coasts, wetlands, and resource corridors, sometimes pausing for generations before moving again. Yet the overall pattern reveals that the maritime pioneers were not specialists capable only of island living. They carried a flexible way of thinking that could be reshaped for deserts, forests, mountains, and seasonal grasslands. The crossing also transformed the sea behind them. Once communities existed on Sahul, the route was no longer merely a path into the unknown. It could become a remembered connection to islands farther west. Whether regular return journeys occurred during the earlier settlement is difficult to prove, but later movement of people, technologies, and ideas shows that the waters between Sahul and Wallacea were not permanently closed. Knowledge of crossing points may have survived in oral tradition for many generations, even as changing sea levels altered the appearance of coasts. One surprising feature of this migration is that it took place long before agriculture cities or formal navigation. The sailors belonged to mobile hunter-gatherer societies, yet their accomplishment required planning on a scale once thought possible only for settled communities. They coordinated labor-managed risk and moved through environments they could not fully see. The evidence does not reveal their ceremonies, fears, or arguments before departure. It cannot tell whether they believed the distant land was inhabited by spirits, ancestors, enemies, or animals. What survives is the outcome: people reached Sahul and remained. Their arrival represents more than the settlement of another territory. It proves that by the deep Pleistocene, Homo sapiens could turn the ocean from a boundary into a route. The crossing may have involved simple technology, but it rested on complex cooperation, memory, and judgment. Each successful voyage carried not only bodies, but language, social knowledge, fire, and inherited skills into a continent separated from the rest of humanity by deep water. Yet the waters of this region may hold an even older secret. Long before modern humans moved towards Sahul, another kind of human had already appeared on an isolated island to the west, leaving behind stone tools, butchered animals, and a mystery that pushes the possibility of seafaring far deeper into the past. The island of Flores lies west of Timor, separated from neighbouring land by channels that remained open throughout the Ice Age. It is long, mountainous, volcanic, and difficult, with steep valleys, seasonal rivers, dry grasslands, and forests shaped by monsoon rains. Today it appears as one island among many in eastern Indonesia. In the deep past, however, Flores becomes the centre of a much stranger problem. Long before modern humans cross Wallacea towards Sahul, another human population is already living there. The evidence does not merely push island settlement back by a few thousand years. It may push it back hundreds of thousands, perhaps close to 1 million, into a period when the sailors involved were not Homo sapiens at all. The first clues come not from human bones, but from stone. At several sites in central Flores, archaeologists uncover simple flake cores and chopping tools made by deliberate striking. Some appear in deposits roughly 700,000 years old, while other finds have been argued to be even earlier. The artifacts are not spectacular. They lack the symmetry of later hand axes and the refinement of much younger technologies. Their importance lies in their location. Flores was never joined to the Asian mainland by an exposed continental shelf. Deep water lay between it and the islands to the west. Whoever made these tools had reached an island that could not be entered on foot. For years the identity of the toolmakers remained unknown. The most obvious candidates seem to be Homo erectus, a human relative already present on Java more than 1 million years ago. Homo erectus possessed a larger brain than earlier hominins, walked fully upright, made stone tools, and spread across large parts of Africa and Eurasia. If a population moved eastward through the Indonesian islands, it might eventually have reached Flores. Yet accepting that possibility raised an uncomfortable question. Could Homo erectus build and use watercraft, or did a small group arrive through an extraordinary accident? The mystery deepened in 2003 when excavators working in Liangbua, a limestone cave in western Flores, uncovered the skeleton of an adult female unlike any human known from the recent past. She stood a little over a meter tall. Her brain was exceptionally small, closer in volume to that of much earlier hominins than to modern humans. Her body combined ancient-looking features with adaptations that appeared unique. Additional remains from other individuals confirmed that she was not simply a modern human with a medical condition. The population was eventually named Homo floresiensis, and the world quickly gave its members a more memorable nickname, the Hobbits. The Liangbua individuals lived far later than the earliest toolmakers, with the youngest widely accepted skeletal remains dating to tens of thousands of years ago. This left a vast gap. Were they descendants of Homo erectus that reached Flores much earlier and evolved in isolation, or did they descend from an even more ancient, smaller-bodied human lineage? Scholars still debate the answer. Their wrist, shoulder, foot and jaw preserve a puzzling mixture of traits. Some resemble Homo erectus, while others appear more primitive. No single explanation fully accounts for every feature. Finds from Matamengia site in the Soa basin of central Flores provide an important bridge. There, teeth and fragments of jaw from small-bodied hominins occur in deposits around 700,000 years old. These individuals were already remarkably small, suggesting that body size reduction happened early in the island's history. The remains are limited, and they cannot reveal the full appearance or brain size of the population, but they strengthen the possibility that Homo floresiensis emerged from a long isolated lineage rather than appearing only recently. Flores itself offers a natural laboratory for such change. Islands often reshape the animals that reach them. Large species may become smaller when food is scarce, and predators are limited, while small species sometimes grow larger when ecological competition changes. Ancient Flores contained dwarf relatives of elephants known as stegodons, some reduced dramatically from the size of their mainland ancestors. It also supported giant rats and Komodo dragons. The island's human population may have undergone a similar process of dwarfing, although body size is influenced by ancestry, development, diet, and many other pressures. What survives in the record suggests long isolation, but the exact evolutionary pathway remains incomplete. The seafaring question is even harder. No boat survives from these remote periods. No paddle rope or worked timber has been found beside the earliest tools. The craft could have been made from bamboo logs, branches, or naturally floating vegetation, all materials unlikely to endure. It is possible that people intentionally constructed rafts and crossed in small groups. It is also possible that storms, tsunamis, or floods swept individuals onto floating debris and carried them eastward. Large mats of vegetation can survive at sea, and animals are sometimes transported naturally between islands in this way. Accidental rafting therefore cannot be dismissed, especially for a single colonization event. A small founding group might reach Flores by chance, survive and reproduce. Yet probability becomes difficult to judge. Human beings need fresh water soon after arrival. A founding population must include enough compatible individuals to persist. The travelers must land on a coast where resources are accessible. Each requirement narrows the odds, though rare events become more plausible when considered across thousands of years. The existence of stegodons and other animals on Flores proves that natural dispersal occurred, but humans are not passive cargo in quite the same way. Even a raft formed by chance could be managed, stabilized, or directed by its passengers. Popular accounts sometimes imagine fleets of Homo erectus confidently navigating from island to island, but the evidence does not support such certainty. Nor does it justify the opposite claim that they lacked all capacity for planning. Homo erectus survived across diverse environments for an immense span of time. These humans made tools, processed animals, controlled movement across landscapes, and likely possessed social abilities that cannot be measured from skulls alone. Their minds were different from those of modern humans, but different does not mean helpless. Flores leaves the argument suspended between archaeology and possibility. Stone tools prove that hominins were present. Geology proves that water had to be crossed. Everything between those two facts, the vessel, the crew, the intention, the fear the moment of landfall, has vanished. The island therefore preserves one of the oldest maritime implications in human history without preserving a single recognizable piece of maritime technology. And Flores is not alone in challenging the boundary between landbound prehistory and deliberate voyaging. Far to the north, another chain of islands lies across one of the strongest ocean currents in the world. There the evidence belongs clearly to Homo sapiens, but the water itself creates a different puzzle, not simply how people floated, but how they crossed a current powerful enough to carry an unguided craft far away from its intended destination. Far north of Flores, the islands of southern Japan form a long broken arc between Taiwan and Kyushu. The Ryukyu chain looks almost like a path laid across the sea, but the map is misleading. Between several of these islands runs the Kuroshio, one of the strongest warm currents in the Pacific. It moves northward along the edge of the Western Ocean, carrying enormous volumes of water, with enough force to turn a short crossing into a dangerous diagonal drift. For Paleolithic travellers, the challenge was not merely to stay afloat until land appeared. It was to enter a moving river within the sea and somehow emerge where they intended. Human remains and archaeological sites show that Homo sapiens reached islands in this region before farming began, in some cases more than 30,000 years ago. The exact settlement history remains difficult to reconstruct because coastlines have changed. Early sites are rare, and warm, acidic environments often destroy organic material. Yet the presence of people on islands separated by deep channels cannot be explained by falling sea levels alone. Even during glacial low stands, water divided the archipelago. Some crossings became shorter, but they did not disappear. One of the most revealing islands is Ishigaki in the southern Ryukyus. At the Shirahosonetabara Caves site, human remains dating to the late Pleistocene indicate that people had reached this part of the island chain by roughly 27,000 years ago, perhaps earlier, depending on which remains and dating methods are considered. Farther north, evidence from Okinawa and other islands adds to the picture of repeated human presence. These populations lived long before rice agriculture formal ports, or the seagoing cultures recorded in written history. Their roots were created in a world of stone tools and perishable boats. The Kuroshio makes accidental arrival possible, but it also makes accidental arrival unreliable. A floating object caught in the current may travel great distances, yet it is not likely to stop conveniently at a small island. The same current that can transport a drifting craft can carry it past land and into open ocean. Wind direction, wave height, departure point, and the shape of the vessel all influence the outcome. A person swept away from Taiwan might be moved northward, but being moved toward the general region is not the same as reaching a habitable shore, with enough survivors to establish a population. Modern researchers have tested these problems through experimental voyages. Some attempts used rafts made from bundled reeds or bamboo materials that Paleolithic people could have gathered and shaped. The results exposed weaknesses that are invisible in simple illustrations. Certain rafts floated well but were difficult to control. Others absorbed water, turned slowly, or were pushed sideways by wind. A vessel that seems adequate near a beach may behave very differently after hours in a strong current. The experiments do not prove exactly what prehistoric sailors used, but they narrow the possibilities by showing which designs are unlikely to complete the crossing under realistic conditions. Dugout canoes offer a more effective solution. A large tree trunk can be hollowed with stone axes, adzes, controlled burning and repeated scraping. The process demands labour and suitable timber, but the finished vessel is easier to paddle and steer than a loose raft. Experimental teams using reconstructed Paleolithic tools have demonstrated that such boats can be built without metal. Crews have also completed challenging journeys through the region in replica canoes, showing that a crossing against the influence of the Kuroshio is physically possible when paddlers understand the current and maintain direction. Possibility, however, is not proof. No Pleistocene canoe has survived from the Ryukyus, and the earliest known watercraft elsewhere are much younger than the first island occupations. Tropical wood decays quickly, while ancient landing places now lie beneath the sea. Archaeologists therefore rely on indirect evidence, human presence on the islands, the impossibility of walking their available raw materials, stoneworking abilities, and the behaviour of reconstructed vessels. Scholars still debate the precise technology, but the basic requirement remains unavoidable. Some form of watercraft carried people across. The crossing from Taiwan toward the southern Ryukyus would not necessarily have followed a straight line. Departing paddlers might aim south or east of their intended destination to compensate for northward drift. They may have waited for seasonal winds that reduced the current's effect, or used weather conditions that made cloud formations above islands easier to detect. High mountains can sometimes be seen at considerable distance, but haze and the curvature of the earth hide low land. A crew might know that an island existed without seeing it throughout the journey, steering by the sun during the day and stars after dark. Such navigation does not require mathematical coordinates. It requires accumulated observation. Fishermen and coastal foragers learn where currents change colour, where floating leaves collect, and where birds appear at certain hours. They notice how ocean swells continue from distant storms, even when local winds fall quiet. They can distinguish clouds formed over warm water from those gathering above land. This knowledge may never be written down, yet it can be precise enough to guide repeated movement. The human cost of failure is impossible to calculate. Successful crossings leave people and artifacts on islands. Failed voyages leave almost nothing. A boat that disappears into the Pacific does not become an archaeological site. This creates a record shaped entirely by survivors. The first successful journey may have followed many attempts that ended beyond sight of land. Families waiting on the departure shore may have watched the horizon for people who never returned. Maritime exploration is often described through achievement, but its hidden history is also one of loss. Once a route succeeded, memory could reduce the danger. Survivors knew the approximate duration, the direction of drift, the behaviour of the current, and the location of fresh water after landing. They could teach others where to launch and when not to leave. Repeated crossings would turn a terrifying unknown into a difficult but recognised passage. The islands themselves could become markers in a mental geography, stretching across hundreds of kilometres. The Ryukyu evidence therefore reveals something more sophisticated than blind movement along visible coasts. These sailors confronted an invisible force capable of carrying them away from land and learned enough to cross it. Their boats are gone, their names forgotten, and their route remains partly uncertain. Yet their arrival shows that long before farming, humans were already solving the practical problems of current direction, endurance, and return. Far to the west in the Aegean Sea, Stone tools on another island would raise an even older and more controversial question about how early this maritime ability truly began. In the middle of the Aegean Sea, Naxos rises above the water as the largest island of the Cyclades, a landscape of pale mountains, valleys, dry slopes, and bright stone. Near its northwestern coast stands a low hill called Stellida. It is not a cave filled with bones or a ruined settlement marked by walls. Its importance comes from the stone beneath it. Stellida contains a rich source of chert, a hard material that prehistoric people repeatedly struck into flakes, blades, scrapers, points, and cutting edges. Across the hill, thousands of discarded fragments record visits extending far deeper into the past than archaeologists once expected anyone to have reached the central Aegean. The site first appeared important because of material scattered across the surface, but excavation revealed more than a loose collection washed together by time. Stone artifacts occurred in buried layers associated with sediments that could be studied and dated. Researchers recovered roughly 9,000 pieces spanning the early Holocene to the Middle Pleistocene. Some artifacts belong clearly to later hunter-gatherers. Others resemble Aurignacian technology associated with early modern humans in Europe. Deeper still are Levallois cores, flakes, and other forms characteristic of the Middle Paleolithic, the broad technological world commonly associated in this region with Neanderthals. The oldest securely dated activity reaches to around 200,000 years ago. This does not mean that a Neanderthal skeleton has been found on Naxos. No hominin bones from Stellida identify the toolmakers directly. Archaeologists infer their likely identity from artifact-style age and the known populations of nearby regions. That inference is reasonable, but it remains an inference. Stone technologies can persist overlap and sometimes be used by more than one human population. The cautious conclusion is that hominins repeatedly visited Stellida long before farming, and that at least some visits probably involved Neanderthals or closely related Middle Pleistocene people. The hill itself explains why they came. Good stone was a strategic resource. A sharp edge could butcher animals, cut hide-shape wood, and repair hunting equipment. Chert could be tested, quarried, reduced into portable cores, and carried elsewhere. The ground at Stellida preserves every stage of this work: blocks broken from the source, failed pieces abandoned after flaws appeared, flakes produced while shaping cores and finished tools. The site was not merely a place where someone dropped a knife. It was a workshop visited again and again because the raw material justified the journey. The journey is where the argument begins. Naxos is an island today, but it did not always have its modern outline. During cold periods, falling sea levels exposed large areas of the shallow Cycladic plateau. Naxos joined Paros and several neighbouring islands into a much larger landmass sometimes described as a Cycladic mega-island. Bays became plains, channels narrowed, and coastlines moved outward. From one glacial stage to another, the geography changed repeatedly. At the lowest sea levels, some reconstruction suggests that parts of the central Aegean may have been connected through exposed terrain and wetland corridors, perhaps allowing hominins to approach Naxos without a major open water crossing. If that reconstruction is correct for the periods represented at Stellida, the oldest visitors may have walked there. Their route would still have been difficult, passing through landscapes altered by colder climates, but it would not demonstrate seafaring. This is why the discovery cannot simply be described as proof of Neanderthal sailors. The date of an artifact must be matched not only with global sea level, but also with local tectonics, the shape of the ancient seabed, and the shifting position of shorelines. Small changes in estimated water level can turn a dry corridor into a strait. The problem becomes more complicated because the dated sequence spans many climatic phases. Some occupations occurred during colder low stands when land connections were most plausible. Others may belong to periods when the Aegean was again filled with islands. During warmer intervals, Naxos and the surrounding high ground would have been separated by water, although distances might still have been shorter than today. If people visited Stellida during these intervals, some kind of crossing becomes difficult to avoid. The artifacts indicate repeated use, but dating each tool closely enough to reconstruct the exact shoreline is rarely possible. Scholars still debate how much maritime ability should be inferred. One view favours caution. Hominins may have used exposed land routes during especially low sea levels, and the present island setting tempts modern observers to imagine boats where none were necessary. Another view notes that Neanderthals and earlier humans were highly mobile, capable of planning movements across difficult terrain, and apparently present on several Mediterranean islands or former islands. Limited crossings on simple rafts may therefore be less extraordinary than older models assumed. The evidence does not require sophisticated navigation, but neither does it allow the sea to be treated as an absolute barrier. Later occupation at Stellida makes the maritime case much stronger. By the Upper Paleolithic and especially the Mesolithic sea levels and island geography mean that visitors had to cross water. These later hunter-gatherers were not merely passing through an accidental landing place. They sought a known stone source and carried its products into a wider Aegean network. The attraction of chert may have helped transform Ireland from distant curiosities into regular destinations. A useful hill could draw people back across the same channels, creating routes maintained by memory and repeated experience. Stellida therefore offers no single dramatic moment when humanity invents the boat. Instead, it preserves a long record in which the relationship between land and sea repeatedly changes. The oldest toolmakers may have walked across exposed terrain, crossed narrow water, or used different methods during different visits. Later groups certainly approached an island. The mystery remains because the coastline moved while the stone stayed still. That stillness gives Stellida its power. Sea levels rise, plains drown, and routes disappear, but the broken chert remains on the hill. Each flake marks an act of choice by someone who recognized the value of this place and reached it somehow. Yet Naxos is only the beginning of the Aegean dispute. Farther south, Crete presents a harsher test because its surrounding waters are deeper, its isolation more persistent, and the claimed tools found there appear to push human arrival into an age when even the identity of the travellers is uncertain. Crete does not offer the comforting ambiguity of a shallow shelf. The island stands in the southern Aegean, separated from mainland Greece and Anatolia by deep basins formed through millions of years of tectonic movement. Sea levels can fall, coastlines can expand, and neighbouring islands can grow larger, but no known Ice Age low stand turns Crete into part of a continent. Anyone reaching it during the Pleistocene must cross open water. This is why a collection of battered stone tools from the island's southwestern coast caused such excitement. If their proposed age is correct, they imply that humans were voyaging to Crete long before modern humans were believed to have entered Europe. The most debated discoveries come from the region around Plakias, where mountains descend sharply toward the Libyan Sea. The landscape is cut by gorges and dotted with caves, terraces, springs, and outcrops of workable stone. Archaeological surveys found artifacts near ancient coastal surfaces, including tools made largely from local quartz. Some resemble hand axes, cleavers' picks, and large cutting implements associated with the Apulian tradition, a technological pattern created by Homo erectus and other early human populations across Africa, Western Asia, and parts of Europe. The Tulan tools are often recognized by their deliberate shaping. A hand axe is produced by removing flakes from both sides of a stone to create a durable cutting edge and a form that can be held comfortably. Yet not every pointed or roughly symmetrical rock is a human artifact. Quartz breaks unpredictably, and natural forces can fracture stone in ways that imitate intentional working. Identifying artifacts therefore depends on repeated flake scars, clear striking platforms, consistent patterns, and the wider context in which the objects are found. Some specialists examining the Cretan material accept that many pieces were deliberately made. Others argue that the collection includes uncertain forms whose resemblance to hand axes may be exaggerated. Even where human workmanship is accepted, age presents a greater problem. Many of the tools were collected from surfaces or from deposits that had been disturbed by erosion. They were not sealed beside bones, charcoal, or volcanic layers that could be dated directly. Researchers instead studied the surrounding geology, including raised marine terraces formed when ancient shorelines stood at different heights relative to the present sea. Some artifacts appeared associated with surfaces believed to be at least 130,000 years old, and claims have been made that portions of the assemblage could be several 100,000 years old. The method is indirect. A geological surface may be ancient, but a stone tool lying upon it could have arrived later. Erosion can move artifacts downhill. Streams can carry them from one deposit into another. Farming, road construction, and natural weathering can expose and mix material from different periods. A tool's shape can suggest a technological tradition, but typology alone cannot provide a precise date. Similar forms may appear independently because people working with similar stone often solve practical problems in similar ways. The evidence remains incomplete, and scholars still debate whether the Plakia's finds truly document a very early Pleistocene crossing, or represent a mixture of younger artifacts resting on older landforms. If the oldest interpretation is correct, the consequences are remarkable. The travellers may have been Homo erectus Neanderthals, or another population whose remains have not been identified on the island. No human fossil has been found beside the disputed tools. They would have crossed distances far beyond a river or narrow tidal channel, probably through a chain of islands rather than in one uninterrupted voyage. Depending on the route and sea level, some stages may have offered visible destinations, while others required movement toward land hidden beyond the horizon. Crete itself would have been worth reaching. Its mountains gathered rainfall and fed springs, valleys supported vegetation and animals, coastal waters offered fish, shellfish, and seabirds. The island also contained dwarf elephants, dwarf hippopotamuses, and other species shaped by long isolation, although whether the earliest claimed visitors encountered particular animals depends on uncertain chronologies. An island with fresh water and predictable resources could support repeated occupation, but a few stone tools do not reveal whether people stayed for generations or arrived only during brief expeditions. The popular image of early humans launching an organized fleet toward Crete goes far beyond the evidence. At most, the finds suggest that some Pleistocene hominins may have possessed basic watercraft and enough social coordination to survive a series of crossings. Rafts of timber reeds or bundled branches could have been built without advanced tools. The vessels need not have resembled later boats. Even a rough platform can carry several individuals under calm conditions, though steering it across the Aegean would demand knowledge of winds and currents. Accidental arrival is possible in theory, but Crete is a difficult target for random drift. Currents could carry people away as easily as toward the island, and a sustainable population would require more than one fortunate survivor. Repeated artifacts from different locations would strengthen the case for deliberate travel, but the present record is too uncertain to establish frequency. No single explanation fully accounts for the finds without leaving unanswered questions. The controversy is valuable precisely because it exposes how archaeological certainty is built. A dramatic conclusion cannot rest only on an object that looks ancient. Researchers need secure layers, reliable dates, repeated patterns, and independent lines of evidence. Extraordinary voyages do not require extraordinary humans, but they do require evidence strong enough to distinguish an actual crossing from a mistaken artifact or a displaced stone. Crete does provide clearer signs of maritime activity at the end of the Ice Age. Mesolithic sites dating to roughly 11,000 years ago show hunter-gatherers visiting or living on the island before fully agricultural communities became established there. These later occupations are far less controversial. They belong to people who exploited coastal resources and moved through an Aegean already connected by water routes. Their presence proves that pre-farming voyagers reached Crete even if the much older claims remain unresolved. The disputed tools therefore occupy a strange position. They may preserve one of Europe's earliest traces of seafaring, or they may be geological and chronological clues pushed beyond what they can securely support. Either way, they remind us that the sea surrounding Crete was not necessarily the empty barrier once imagined. By the closing millennia of the Ice Age islands across the Aegean were clearly part of a human world. The strongest evidence would soon come not from controversial hand axes, but from a black volcanic glass carried repeatedly across the sea. On the island of Melos, the earth produces a stone unlike the pale limestone and dull chert found across much of the Aegean. It is black, glossy and sharp enough to form an edge finer than many metal blades. Obsidian begins as volcanic lava, rich in silica, cooled so rapidly that crystals have no time to grow. The result is natural glass. When struck with skill, it breaks in predictable curves, releasing flakes with razor-like margins. To a hunter-gatherer, a small block of good obsidian can become knives, scrapers' piercing tools, and delicate points. To an archaeologist, it offers something even more valuable, a material whose geological origin can often be identified with remarkable precision. Every volcanic source carries a distinctive chemical signature created by differences in trace elements. A fragment found far from its quarry can therefore be compared with known outcrops and linked back to the island where it formed. This transforms obsidian into a map of prehistoric movement. Ordinary stone may come from many similar-looking places, but Melian obsidian announces its birthplace. When it appears at a mainland cave or on another island, it proves that either people or objects have crossed the intervening sea. At Franchthi Cave in the eastern Peloponnese, archaeologists found obsidian from Melos in layers dating to the final part of the Ice Age. The cave overlooks what is now a sheltered bay, though the shoreline during the late Pleistocene lay farther away across an exposed coastal plain. Its inhabitants hunted terrestrial animals, gathered wild plants, collected shellfish, and gradually expanded their use of marine resources. Among their stone tools were small quantities of black volcanic glass that could not have come from the mainland. Melos lay roughly 100 kilometers away by a plausible maritime route, with intervening islands and different coastlines depending on sea level. The earliest pieces are few, and that scarcity is important. They do not suggest bulk cargoes arriving in fleets. They may represent rare expeditions, treasured objects passed between groups, or small cores carried by travellers who move through several communities. Yet even a handful is enough to establish connection. Obsidian cannot swim, and no land bridge joined Melos to the Peloponnese. Someone reached the volcanic island, collected the stone, and carried it away across water. The voyage was probably not a single blind crossing from one distant coast to another. Lower sea levels enlarged the Cycladic islands and reduced some distances. Travellers could move through stages using high points to locate the next landmass and stopping at islands along the way. Even so, several passages remained unavoidable. A crew had to choose weather conditions, manage water and food land on rocky shores, and return with added weight. The route demanded more than one successful journey if the supply continued across generations. Melos itself may not have supported large permanent hunter-gatherer populations during every period of use. Freshwater availability, vegetation, and seasonal resources would have influenced how long visitors remained. The obsidian source may therefore have functioned as a specialized destination rather than an ordinary residential island. People came because the material justified the risk. They knew where to find it, how to recognize high-quality nodules, and how much stone their craft could carry safely. This introduces a different kind of seafaring from the migration into Sahul. The first settlers of a new continent crossed water in order to reach land where they could live. The visitors to Melos may have crossed repeatedly to obtain a particular resource and then returned. Such movement requires a route that can be remembered in both directions. It implies not only discovery, but maintenance. Knowledge of departure points seasonal winds, landing beaches, and the location of the quarry must survive from one expedition to another. Obsidian may also have travelled through exchange. A person using Melian glass at Franchti did not necessarily visit Melos personally. One coastal group could obtain the stone and pass part of it to another community through meetings, marriages, shared hunting territories, or seasonal gatherings. The object might move across several stages before reaching its final user. Archaeology rarely reveals the exact number of hands involved, but the distribution of material traces a social network wider than any single campsite. The shape of the artifacts offers further clues. Some obsidian reached distant sites as partially prepared cores from which useful flakes could be removed as needed. Transporting a core wastes less space than carrying raw stone filled with poor quality material. In other cases, the stone appears as finished blades or small tools. These choices suggest planning. Voyagers did not simply collect whatever they found. They tested, reduced, and packaged the material in form suited to movement. By the Mesolithic, after the coldest phase of the Ice Age had ended, Aegean maritime activity becomes increasingly visible. Sea levels rise, drowning coastal plains and separating islands more sharply. Paradoxically, the growing sea does not isolate people completely. Communities exploit tuna shellfish and other marine foods. Obsidian continues to circulate. Sites on Crete, the Cyclades, and the mainland reveal movement through a landscape where water has become a normal part of travel. Fishing large migratory species adds another layer. Tuna do not wait conveniently in shallow pools. They move through open water and demand timing observation and equipment. Evidence for their exploitation suggests that some groups ventured offshore or developed effective ways to intercept them near coasts. Hooks, lines, nets, spears, baskets, and boats were largely made from organic materials and have mostly disappeared, but fish bones preserve the result of these vanished technologies. The Aegean record does not reveal a single maritime revolution. Instead, it shows increasing density. Rare pieces of obsidian appear early. Later deposits contain more material, wider distributions, and stronger evidence of repeated contact. What begins as an occasional crossing becomes a network. Routes once known to a few crews may gradually enter the shared geography of many communities. Scholars still debate whether the earliest Melian obsidian reached the mainland through direct voyages down the line exchange or a combination of both. The evidence cannot identify the first sailor who found the source or the exact vessel used. Yet its chemical signature makes the central conclusion unusually secure. Long before farming villages spread across the Aegean, hunter-gatherers were already connecting islands through deliberate movement. The black glass survives where boats do not. It lies in caves and camps as a hardened trace of journeys made over vanished seas. Each fragment carries the memory of volcanic cliffs, paddled crossings, guarded knowledge, and human relationships stretching beyond the visible horizon. Farther east, another island would reveal an equally important stage in this maritime story. Not merely a place visited for stone, but a land where hunters arrived before farmers and began testing whether an isolated island could become a home. East of the Aegean, Cyprus rises from the eastern Mediterranean as a large island with high mountains, forested slopes, river valleys, and broad coastal plains. It lies close enough to Anatolia and the Levant to appear almost within reach, yet it has been isolated by deep water for millions of years. Even when Ice Age sea levels fall, no land bridge connects it to the surrounding continents. Any human presence on Cyprus therefore begins with a voyage. For a long time, archaeologists believed that this voyage occurred only after farming communities had already formed on the mainland. The island seemed to fit a familiar pattern. Agriculture created permanent villages. Villages created population pressure, and organized settlers carried crops and livestock across the sea. Then evidence began to appear that people had reached Cyprus before that sequence was complete. The most famous early site is Akrotiri Itokremnos, a rock shelter on a southern coastal cliff. Today it overlooks the sea from a dramatic height, but near the end of the Pleistocene the shoreline lay farther away across an exposed plain. Excavations uncovered hearths, stone tools, shells, bird bones, fish remains, and immense quantities of bones belonging to Cyprus's extinct dwarf hippopotamuses. Radiocarbon dates place the activity around 12,000 years ago, just before or during the wider transition from mobile hunting and gathering to agriculture in the surrounding region. The dwarf hippopotamuses were one of the island's strangest inhabitants. Their ancestors probably reached Cyprus by swimming or drifting from the mainland in the remote past. Once isolated, they became much smaller than ordinary hippos, an example of the island dwarfing seen in many large mammals. Adult animals stood only around the height of a large pig, though they remained heavily built and potentially dangerous. Cyprus also supported dwarf elephants, unusual rodents, reptiles and birds, creating an ecosystem shaped by long separation from mainland predators. At Itokremnos, burned and broken hippo bones occur near traces of human activity. This led to the dramatic suggestion that hunter-gatherers reached Cyprus and helped drive the animals to extinction. The image is compelling. Boats land on an island filled with slow-breeding mammals, unfamiliar with human hunters, and within a short time the newcomers transform the ecosystem. Similar patterns are known from later island colonizations around the world, yet the Cypriot case remains disputed. The bones may have accumulated naturally before humans used the shelter. Some could have been carried by predators washed into the site or gathered over a long period. Fire may have affected old deposits after the animals were already dead. The relationship between stone tools, hearths, and hippo remains is not perfectly clear in every layer. Scholars still debate whether people actively hunted the animals, scavenged their carcasses, burned older bones as fuel, or simply occupied a place where hippos had accumulated earlier. The evidence remains incomplete, and the temptation to tell a simple extinction story must be resisted. What cannot easily be dismissed is the presence of humans. Stone artifacts and food remains indicate that people visited the location before established farming villages appeared on Cyprus. These travellers were likely connected to Epipaleolithic communities along the Levantine or Anatolian coasts, where hunter-gatherers had developed increasingly settled lifeways, while still relying heavily on wild resources. They possessed no metal tools or sails, but they lived in a region where coastal travel, fishing, and short-distance maritime movement were already familiar. The shortest route to Cyprus still required a substantial open-water crossing. Depending on sea level and departure point, voyagers may have faced distances of several dozen kilometers or more. In clear conditions, high mountains on the island could sometimes be visible from far away, especially from elevated mainland ground, but visibility would vary with haze, cloud, and season. A crew leaving shore might know its destination existed while losing sight of both coasts during part of the journey. The craft used for these voyages has disappeared. Dugout canoes, timber raft, reed boats, or composite vessels are all possible. Whatever the design, it had to carry several people, stone tools, drinking water, food, and fire-making materials. A return journey required additional supplies and confidence that winds and currents would allow the travellers to find the mainland again. The presence of marine foods at early sites suggests that these people were not strangers to water. They understood shorelines as productive landscapes and boats as practical tools rather than extraordinary inventions. Early visits may have been seasonal. Small parties could cross to hunt birds, gather shellfish, collect plants, fish coastal waters, or investigate the island's animal populations. They might remain for days, weeks, or months before returning. Temporary camps leave faint traces, especially when later erosion destroys coastal surfaces. A handful of tools does not necessarily indicate permanent settlement, yet repeated visits can gradually alter both knowledge and ambition. Each successful landing reveals freshwater sources, sheltered beaches, stone outcrops, and routes through the interior. An island that begins as an uncertain destination becomes a mapped and remembered landscape. Cyprus offered several attractions. Its forests supplied timber and fuel. Coastal wetlands supported fish and birds. Chert and other stone could be shaped into tools. The absence of large mainland predators may have made some resources easier to exploit. At the same time, island life imposed severe limits. Drought could reduce fresh water. A small animal population could be exhausted quickly. Storms might prevent return voyages for weeks. A group cut off from the mainland had to survive with whatever the island provided. By the early Holocene, human activity becomes more substantial. Sites indicate that people were not merely arriving by accident, but moving repeatedly between Cyprus and surrounding coasts. Soon after, settlers transported plants and animals that did not naturally occur on the island. Wild boar appear to have been introduced surprisingly early, possibly before fully developed farming. Carrying live animals across the sea required restraint, space, and planning. It suggests that voyagers were beginning to reshape the island intentionally, perhaps releasing animals to establish future hunting populations. This practice blurs the line between hunter-gatherer exploration and agricultural colonization. The first visitors did not necessarily arrive with fields, houses, and domestic herds. Instead, maritime knowledge accumulated gradually. Hunters learned the route. Camps became more familiar. Resources were transferred. Longer stays became possible. Eventually, communities established permanent settlements and brought the full package of cultivated cereals, managed animals, architecture, and village life. Farming, therefore, did not create the route to Cyprus from nothing. It inherited a route already tested by people whose lives remained rooted in hunting, gathering, fishing, and mobility. The later settlers may have used better organized voyages and carried heavier cargoes, but they crossed a sea that earlier sailors had already entered. Cyprus preserves that transitional moment when an island shifts from a distant place of occasional visitation to a landscape incorporated into human plans. The first crews could not know what their crossings would begin. They sought food-stone animals or new territory. Behind them lay familiar coasts. Ahead stood an isolated ecosystem with no memory of human presence. Their landings would eventually contribute to extinctions, introductions, permanent villages, and a completely transformed island. But before Cyprus became a settled agricultural world, it was reached by sailors whose economy still belonged to the Ice Age. An island seen from the sea is first a shape, then a promise. A dark ridge may suggest trees and fresh water. White birds circling above a headland may indicate nesting colonies. Smoke can reveal lightning fires or another human camp. The colour of the water may change where reefs rise near the surface, while floating branches, seeds, insects and leaves hint that land lies somewhere beyond the horizon. For Ice Age, Voyagers' Islands were not empty dots on an unknown map. They were concentrations of possibility places where food, stone shelter and safety might exist, within boundaries small enough to learn but dangerous enough to punish every mistake. The most immediate attraction often waited along the shore. Rocky coasts could hold dense beds of limpets, mussels, oysters, crabs and other shellfish. These foods did not need to be chased across mountains or wounded with a spear. They could be gathered at low tide, carried to a hearth and opened with heat or stone. Fish moved through lagoons, estuaries, reefs and channels. Seabirds nested in large colonies where eggs and young could be collected seasonally. Turtles came ashore to lay eggs. Seals rested on beaches in colder regions. Even a small island might offer several food sources within a short walk of a landing place. Shellfish were especially valuable because they reduced uncertainty. Large game hunting could fail for days, but a known tidal flat might provide food with greater regularity. Shell middens found at prehistoric coastal sites record repeated harvesting, though many early examples have vanished beneath rising seas. The surviving deposits often contain thousands of broken shells mixed with charcoal fish, bone stone flakes and burned rock. They show that shorelines were not merely temporary edges crossed on the way inland. They were productive habitats studied in detail. Yet coastal abundance could be deceptive. A shell bed stripped too heavily might recover slowly. A bird colony disturbed at the wrong season could disappear. Fish runs might fail because of storms, temperature changes or shifting currents. Fresh water could become brackish during drought. An island that looked rich during 1 week might become unforgiving months later. Successful occupation therefore depended on timing and restraint, whether consciously managed or learned through painful experience. Larger animals created even stronger temptations. Islands often preserved populations that had evolved with few predators. Dwarf elephants, dwarf hippos, giant tortoises, flightless birds, large reptiles, and unusually bold mammals appear in island ecosystems across the world. Some were easier to approach than mainland prey accustomed to hunters. Their meat, fat, bone, hide, and eggs could support visiting groups, while their unfamiliar behavior may have made early encounters remarkably productive. But island animals were also vulnerable. Their populations were small, their breeding rates often slow and escape routes limited. A mainland herd could move into another valley after heavy hunting. An island species had nowhere else to go. Human arrival did not always cause immediate extinction, and climate change habitat shifts. Volcanic events and natural population decline also played roles. Still, the pattern is repeated often enough to be troubling. Once people fire, introduce predators, and new competitors enter an isolated ecosystem, animals that survived for hundreds of thousands of years can disappear with startling speed. The fate of such species is rarely preserved as a simple sequence. Archaeologists may find animal bones beneath, beside, or above evidence of human occupation, but determining whether people hunted the final survivors is difficult. Dating ranges overlap. Sediments are disturbed. Bones may accumulate naturally in caves. Cut marks can be ambiguous, and burning may occur long after death. Scholars still debate many individual cases, including Cyprus's dwarf hippopotamuses and several extinct animals of Wallacea and Sahel. No single explanation fully accounts for every disappearance. Plants offered opportunities that are harder to detect. Islanders could gather nuts, fruits, tubers, seeds, greens, and medicinal plants. Some required grinding, soaking, roasting, or repeated washing to remove toxins. Knowledge of these processes had to be developed locally or adapted from similar mainland species. Starch grains preserved on stone tools and microscopic plant remains in sediments occasionally reveal this invisible diet, but most plant food leaves little archaeological trace. A site filled with animal bone can therefore create the false impression that meat dominated every meal. Woodlands supplied more than food. Straight trunks could become paddles digging sticks, spears frames, or sections of watercraft. Bark could be turned into containers or coverings. Fibers from palms, vines, grasses, and inner bark could be twisted into cordage. Resin and plant gums might bind stone points to shafts or seal gaps in a vessel. Firewood was essential, but so was dry tinder carried carefully between camps. On a small island, poor use of timber could eventually make boat repair more difficult, trapping a community that had consumed the very material needed to leave. Stone could make an otherwise modest island strategically important. Melos drew visitors because of obsidian. Stellida offered chert. Other islands contained basalt quartz ochre or fine-grained rock unavailable elsewhere. A quarry could support repeated expeditions even where food and fresh water were limited. Voyagers might arrive, test blocks reduce them into portable forms and depart quickly. The island's value lay not in permanent settlement, but in a resource worth crossing water to obtain. Fresh water remained the decisive limit. A green coastline did not guarantee drinkable water. Rain could vanish into porous limestone. Springs might flow only during wet seasons. Small streams could dry completely. Travelers had to recognize vegetation associated with groundwater, collect rain in containers, follow animals, or dig into damp sand above the high tide line. Water stored in skins, gourds, wooden vessels, shells, or tightly woven baskets extended the range of a boat, but every container added weight. Fire posed another contradiction. It made islands habitable by providing warmth protection, cooked food, hardened wooden tools, and a way to clear dense vegetation. Yet fire could also race through dry island landscapes. Some ecosystems had evolved with natural burning, others were highly sensitive to it. Repeated human fires might create open grasslands, improve hunting visibility, encourage useful plants, or destroy forest needed for shelter and boats. The same technology that supported settlement could gradually transform the island beyond recognition. Isolation also changed human risk. A small group might enjoy safety from hostile neighbors or mainland predators, but injury, disease, infertility, or conflict could become catastrophic when no nearby population existed to absorb losses. Storms could prevent contact for months. A failed harvest or contaminated spring might threaten everyone at once. Social ties across water therefore mattered as much as food. Marriage partners, visitors, tools, and information moving between islands helped prevent communities from becoming biologically and culturally isolated. Islands were thus neither natural paradises nor barren prisons. They rewarded knowledge and punished miscalculation. Their resources drew sailors outward, but their limits demanded planning, seasonal memory, and continued connection to other shores. Every successful landing expanded the human world, yet every camp remained dependent on technologies that archaeology almost never preserves. The most important among them were the boats themselves, structures of wood reeds, fibre, fire, and labour that carried people toward these opportunities and then disappeared almost completely from the record. The vessels at the centre of this story have almost entirely vanished. Stone survives because it resists decay. Bone sometimes survives when soil chemistry is kind. Wood, bark, reeds, hide, and cordage do not. A boat abandoned on a tropical beach may begin to split within months. Insects enter it. Fungi soften it. Storms scatter its pieces. A craft lost at sea may sink into deep water, break apart against reefs, or become buried beneath sediments, far from any site archaeologists know to search. Even when ancient wood survives in waterlogged ground, the earliest coastal landscapes have often been drowned, eroded or covered by many meters of marine deposit. The absence of Ice Age wrecks is therefore not evidence that boats did not exist. It is exactly what the materials and environments lead us to expect. The oldest surviving watercraft known from archaeology are much younger than the first recorded crossings into Wallacea or Sahul. Dugout canoes preserved in European wetlands date to the early Holocene, when farming was beginning in some regions but had not yet reached others. Paddles and worked timber from similarly waterlogged contexts show considerable woodworking skill. These finds prove that prehistoric people could hollow large trunks and shape efficient vessels using stone tools, fire wedges, and patient labor. They do not reveal the exact form of boats tens of thousands of years earlier, but they demonstrate that metal was unnecessary. A dugout begins with a tree. The builders must choose a trunk long enough, straight enough, and free from flaws likely to split under stress. Felling it with stone axes can require days of repeated blows with fire, sometimes used to weaken the base. Once the trunk lies on the ground, its outer surface is shaped, and the interior gradually hollowed. Controlled burning removes wood efficiently, but the flame must be watched so it does not crack the hull or consume the sides. Charred material is scraped away with stone adzes and flakes. The builders repeatedly test thickness, balance, and buoyancy. A canoe made too narrow may roll. One left too heavy may be difficult to launch or paddle. Experimental archaeology has shown that these techniques are demanding but entirely practical. Replicas built with stone implements can carry crews across exposed water and can be steered with considerable precision. Such experiments do not prove that every early voyager used dugouts. Suitable trees may have been unavailable on dry islands, and the labor investment might have been too high for groups moving frequently. But the trials remove one supposed obstacle. Ice Age toolmakers possessed the mechanical ability to shape timber into a seaworthy hull. Rafts may have been more common in some regions. Several logs lashed together create a stable platform resistant to capsizing. Though heavy timber can be slow and difficult to direct, bamboo offers a lighter alternative. Its hollow sections contain air, and mature stems can be bundled with vines or fiber ropes. Bamboo grows widely in parts of Southeast Asia, making it an attractive candidate for early crossings through Wallacea. Yet bamboo rafts behave differently depending on species construction and time in the water. Cut stems can lose buoyancy, bindings can loosen, and a broad raft may be pushed strongly by wind. A craft capable of crossing a calm lagoon may fail in ocean swell. Reed boats present another possibility. Bundles of buoyant stalks can be tied into long curved forms, sometimes with raised ends that ride over waves. Reeds are easy to gather in wetlands and can be replaced without felling large trees. Their weakness is gradual water absorption. A vessel may float well at launch and sit dangerously low after many hours. Coatings of resin fat or plant material could slow saturation, but there is no direct evidence that the earlier sailors used such treatments. A simpler craft might combine many materials, a framework of branches, a deck of bamboo bundles of reeds for flotation, and lashings made from twisted bark or vines. Some vessels may have used inflated animal skins or hide stretched over wooden frames, especially in regions where timber was scarce. The categories familiar today, raft, canoe, skin boat, may be too rigid. Prehistoric builders probably adapted whatever materials grew near their coast and altered designs after success or failure. Cordage is the hidden technology holding many of these possibilities together. A raft without reliable bindings becomes a collection of floating logs. Plant fibers must be stripped, soaked, twisted, and joined into length strong enough to resist repeated movement. Knots must hold while wet but remain repairable. Archaeological fragments of Paleolithic cord are rare, yet impressions in fired clay, microscopic fiber traces and wear on tools show that humans were making string nets, baskets, and bound objects deep in prehistory. Neanderthals may also have produced twisted fiber. Rope appears humble, but without it many forms of shelter, clothing, hunting equipment, and watercraft become impossible. Paddles are equally likely to vanish. A branch with one end flattened may serve for a short journey, while a carefully shaped blade improves power and control. Poles can push a craft through shallows but become useless in deep channels. A steering paddle placed at the stern can correct drift, though effective use depends on coordination among the crew. Several paddlers working without rhythm waste energy and turn the vessel. The crossing itself, therefore, requires learned group movement, not merely possession of a floating platform. Boats also need maintenance. Salt water enters cracks. Bindings stretch. Hulls dry and split when left in the sun. Marine organisms attack submerged wood. A crew travelling among islands may carry spare fibre resin, cutting tools, and replacement paddles. Beaches suitable for repair become part of the route. A damaged craft can be pulled ashore, overturned, dried, scraped, rebound, and relaunched. The archaeological trace of such a repair camp might consist only of a few flakes, charcoal, and discarded cordage that soon disappears. Fire is central to boat building but dangerous near the finished vessel. It can hollow a log, harden, paddle blades produce resin, and shape curved timbers through heat. It can also destroy weeks of work in minutes. Knowledge lies in controlling intensity using embers rather than open flame, protecting thin sections with wet clay and scraping char before the heat penetrates too deeply. These techniques may have been taught through demonstration, rather than explanation carried in the hands of specialists whose expertise left no written record. The builders did not need to understand buoyancy as a formal law. They understood it through repeated tests. A vessel loaded with stones could be pushed into shallow water before people boarded. Marks on the hull might show a safe waterline. Cargo could be distributed until the craft sat evenly. Children and supplies could be placed near the centre while strong paddlers occupied the sides. Experience converted dangerous trial and error into tradition. No single design can be assigned to all Ice Age sailors. The dugout that suits a forested Japanese island may be wasteful on a bamboo-rich coast. The raft that survives a short Indonesian passage may be unable to fight the Kuroshio. Scholars still debate which craft were available in each region, and experimental voyages reveal possibilities rather than definitive answers. What survives in the record suggests technological diversity shaped by local plants, waters, and social needs. The missing boat should not be imagined as crude accidents awaiting improvement by later civilizations. They were working machines refined within the limits of available materials. Some undoubtedly failed. Others carried families, tools, food, and inherited knowledge across channels that had stopped animals for millions of years. Their builders left no shipyards, no carved plans, and no wrecks we can confidently recognize. They left islands populated on the far side of deep water, which may be the clearest surviving imprint any boat could make. A boat can be built on land, tested in shallows, and repaired on a beach, but once the shoreline begins to shrink behind it, a different technology becomes essential. The sailors must know where they're going without roads markers or instruments. They have no compass needle, no written chart, and no numerical system for fixing latitude or longitude. Yet the sea is not featureless to anyone who spends enough time upon it. It is filled with direction, motion, colour, sound, and repeated behaviour. Ice Age voyagers did not need modern navigation to cross open water. They needed attention sharpened by memory. The first guide was often the land itself. Mountains could remain visible long after low coastlines disappeared. A distinctive ridge, volcanic cone or cliff might anchor a route across tens of kilometers. Voyagers could climb hills before departure to study the position of an island relative to sunrise, sunset, or a familiar headland. When the destination was hidden beyond the horizon, they could still begin along a remembered bearing. The angle of the morning light, the direction of prevailing wind, and the shape of the departing coast provided an initial course before the land behind them faded. Clouds could reveal what the curvature of the earth concealed. Islands influence the air above them. Warm slopes lift moisture, forests release water vapor, and high ground encourages clouds to form or remain stationary. A cloud bank that persists while others drift away may indicate land below. Light reflected from a pale lagoon can tint the underside of clouds, while dark vegetation can create a different tone. Such signs are subtle, easily missed by an inexperienced traveler, but repeated observation turns them into information. A sailor does not need to see the island itself if the sky announces its presence. Birds provide another moving map. Some seabirds spend days far offshore and reveal little about nearby land, but others feed at sea and return to nests each evening. Their direction changes with the hour. A flock flying outward after sunrise may lead away from land, while birds moving steadily at dusk may point toward it. Species matter, as do altitude, speed, and behavior. A single bird proves almost nothing. A repeated stream of the same species traveling in one direction can be far more useful. Hunters who already understand animal tracks on land can extend the same reasoning into the air. The water carries signs as well. Leaves, branches, seeds, insects, pumice, and freshwater plants may drift outward from coasts. Their freshness gives clues to distance. Muddy water can extend beyond a river mouth. Reefs alter wave patterns and change the color of the sea. Near shallow ground, waves become steeper and break differently. Even smell may matter. Forest smoke, rotting vegetation, seabird colonies, and wet earth can sometimes be detected before land becomes visible, particularly at night or in heavy haze. Most important of all is the ocean swell. Wind creates local waves, but long swells travel far from the storms that formed them. They continue beneath changing surface conditions and can maintain a relatively stable direction for hours or days. A skilled sailor can feel these patterns through the motion of a vessel. When two swells intersect, the sea develops a recognizable rhythm. Islands bend, block, and reflect waves, creating interference patterns that may signal nearby land. This knowledge is strongly documented among later traditional navigators in the Pacific, though scholars cannot assume that every Ice Age community possessed the same elaborate system. Still, the physical signs existed, and people repeatedly exposed to the sea could learn to use them. Currents demanded equally careful attention. They were not invisible abstractions, but forces felt against paddles and hulls. Foam lines, floating debris, temperature changes, and ripples on the surface could mark boundaries between moving bodies of water. A crew crossing a strong current might deliberately aim to one side of its destination, allowing drift to carry the vessel onto the correct approach. This required estimating speed, direction, and travel time without calculation in the modern sense. Knowledge could be expressed through landmarks and action leave. When the sun reaches a certain position, keep a particular swell against one side of the hull, and turn when a specific island disappears. The sky extended navigation beyond daylight. Stars rise and set in consistent regions of the horizon, and some remain useful for maintaining direction through the night. The moon illuminates waves and clouds, though its changing position can mislead anyone relying on it too simply. Familiar constellations may have served as seasonal and directional markers embedded in stories that preserved practical information. The evidence remains incomplete because oral knowledge leaves no direct archaeological trace. Yet humans everywhere observe the sky, and communities whose survival depends on travel are especially likely to remember regular celestial patterns. Time itself could be measured through bodily and environmental rhythms. The length of a crossing might be remembered as the number of rest songs, paddle changes, or movements of the sun. Thirst, fatigue, and the cooling of the air after sunset provided rough intervals. Routes were probably not described as abstract distances but as sequences paddle. Until the high island sinks behind the sea, follow the afternoon wind, watch for birds, then expect the destination after darkness. Such instructions combine navigation with endurance and make sense only within shared experience. Teaching was therefore as important as observation. A young paddler could learn near shore before being trusted on a longer crossing. Elders might point out cloud forms, current lines, dangerous reefs, and stars from beaches where mistakes were survivable. Stories could preserve the memory of storms, lost crews, forbidden seasons, and landing places without sounding like technical manuals. Repetition transformed private skill into collective knowledge. If one navigator died, the route did not have to die with that person. Not every voyage succeeded, and not every sign was reliable. Birds changed course, clouds formed over open water, winds reversed unexpectedly. Volcanic haze erased landmarks. A current stronger than expected could push a boat beyond its target. The sea remained dangerous precisely because experience reduced risk without eliminating it. Scholars still debate how complex the earliest navigational systems were, and there is no basis for imagining precise prehistoric charts comparable to those of much later oceanic societies. What survives in the record suggests competence, not perfection. Return voyages provide the strongest reason to take that competence seriously. Reaching an island once may result from luck. Carrying obsidian away from Melos, revisiting a quarry, maintaining contact between islands, or transporting animals to Cyprus requires remembered routes in both directions. The signs used outward are not always useful on the return. Winds, currents, and the position of the sun differ. Sailors must understand the journey as a changing pattern rather than a single line. Navigation before maps was therefore not navigation without knowledge. The map existed in memory distributed across people, seasons, stories, and bodily skill. It was carried in the eye that noticed a fixed cloud, the hand that felt a cross-current through the paddle, and the ear that recognized waves breaking on an unseen reef. These abilities did not make every crossing deliberate, but they made deliberate crossing possible. The remaining question is why people chose to leave at all, and whether the earliest island arrivals were planned journeys, accidental disasters, or something between the two. The first voyage to an island may begin with intention, curiosity, hunger, fear, or simple misfortune. Archaeology rarely preserves motive. It records arrival, not decision. A scatter of stone tools on a distant shore proves that someone reached the island, but it does not reveal whether the travellers aimed for it from the beginning, spotted it while fishing, followed birds into unfamiliar water, or survived a storm that destroyed every plane they had made. This uncertainty has shaped one of the longest debates surrounding early seafaring. Were the first island populations created by accident, or did prehistoric people deliberately cross open water? Accidental drift is not an absurd explanation. Storms can tear rafts, canoes, or floating vegetation away from coasts. Floods can carry people, animals, and debris into the sea. Tsunamis may sweep survivors outward on pieces of timber. Fishing parties can lose sight of land in fog or be pushed beyond their familiar waters by sudden winds. Ocean currents sometimes carry living passengers across surprising distances. Reptiles, rodents, and other animals have colonized islands without building vessels or choosing destinations. Human beings could also arrive through rare combinations of weather-buoyant material and extraordinary luck. Over thousands of years, even an unlikely event may eventually occur. If coastal populations regularly use simple rafts in rivers, lagoons, or nearshore fishing, some craft will inevitably be carried farther than intended. A single successful landing may leave an archaeological trace, while hundreds of failed drifts vanish without evidence. The record is biased towards survivors. Every tool found on an island belongs to a journey that ended on land. No comparable archive preserves those who disappeared into deep water. This makes accident especially plausible for isolated early appearances represented by only a few artifacts. The first hominins on Flores, for example, may have arrived in one rare event involving a small group carried eastward during a storm. Their descendants could then remain separated for hundreds of thousands of years. No sophisticated navigation is required if the colonization happened once, and the population never maintained contact with its point of origin. The same argument can apply to animals that reached Flores and evolved into dwarf or giant forms, yet accidental drift becomes less convincing when the evidence indicates repetition. A quarry visited across generations, a material transported away from its source, or an island occupied several times after abandonment implies that people knew where the destination was. Melian obsidian appearing at mainland sites does not represent passengers helplessly blown away from home. Someone reached Melos, found the volcanic glass, collected it, and brought it back across the Aegean. Even if the island was discovered accidentally, its later use became deliberate. Return journeys are particularly difficult to explain through chance. Winds and currents that carry a vessel toward an island may not carry it back. A crew returning with stone food or information must choose a departure time and direction. Repeated movements suggest that routes were learned, remembered, and taught. The boats may have drifted while crossing, but drift was then a force managed within a plan rather than the cause of the voyage itself. Permanent settlement demands still more. A lone survivor or a few individuals may live for years on a fertile island, but they cannot create a population lasting many generations unless the founding group is large enough and socially balanced. Colonization requires women and men of reproductive age or repeated arrivals that gradually build a viable community. Children may also be present, increasing the need for water, food, shelter, and vessel stability. The transport of an entire social group looks very different from an accidental fishing mishap. Researchers use demographic models to estimate how many founders might be required, but the numbers depend on assumptions about fertility, mortality, age structure, and later contact. No calculation can tell exactly how many people first reached Sahul. Still, the survival and expansion of its early population strongly suggest more than one fortunate castaway. Multiple voyages, organized group movement, or a substantial initial crossing provide more plausible explanations. Exploration may occupy the wide space between accident and migration. People do not need to launch with the intention of settling a continent. They may begin by extending familiar activities slightly farther offshore. A fishing trip follows a school of tuna. A hunting party crosses to a visible islet used by nesting birds. A crew reaches a high point, sees another island beyond, and returns home with news. Each journey adds a little to the known world. What begins as seasonal foraging becomes repeated visitation, and repeated visitation eventually makes settlement possible. This gradual process may explain many island chains better than the image of one heroic expedition. Routes through Wallacea could have developed step by step. A group familiar with one crossing attempts another from the new island. Some voyagers return, others remain for a season. Knowledge accumulates until a chain of separate shores becomes a connected maritime landscape. The final movement into Sahul may have felt less like crossing into an unknown continent and more like continuing a pattern already practiced for generations. Motives were likely mixed. Population pressure may have encouraged some departures, but prehistoric communities were not constantly fleeing overcrowding. Curiosity, social conflict, marriage, access to stone, seasonal food, and the search for new hunting grounds could all draw people across water. Islands visible from a coast would invite speculation. Smoke might reveal other humans. Birds carrying food could suggest rich nesting grounds. A distant mountain might simply become part of the mental world long before anyone reached it. Danger did not prevent exploration because remaining on land was never free of danger. Drought predators, injury conflict, and failed hunts threatened terrestrial life as well. A risky crossing could lead to beaches without competitors, animals unused to hunters, abundant shellfish, or stone unavailable at home. The balance between risk and reward changed with season experience, vessel quality, and the needs of the group. Fringe theories sometimes imagine lost Ice Age civilizations directing great fleets across the oceans. No archaeological evidence requires such societies. The known crossings can be explained through small communities using organic craft, detailed environmental knowledge, and repeated experimentation. Their achievements become no less impressive when separated from unsupported claims. Complexity does not always leave monuments. A society can master a sea route while remaining mobile, egalitarian, and materially modest. At the opposite extreme, portraying every early arrival as an accident underestimates prehistoric judgment. Hunter-gatherers planned migrations, organized collective hunts, maintained exchange networks, and preserved knowledge across generations. They were capable of evaluating weather-building vessels and choosing destinations. Their technology was simple in material terms, but the decisions behind it could be highly sophisticated. No single explanation fully accounts for every island. Floras may preserve an ancient accidental colonization, while Melos records planned procurement and Sahul points toward coordinated migration. Cyprus may have progressed from exploration to seasonal visits and finally settlement. The first voyage and the later pattern need not share the same motive. Chance could reveal an island. Intention could turn it into a destination. The most defensible conclusion is therefore not that all Ice Age sailors were explorers, nor that they were merely survivors of storms. They occupied a spectrum between the two. Across generations, accidental knowledge became deliberate knowledge, and dangerous water became a route. By the time farming communities began spreading through the Mediterranean and beyond, they were not entering an untouched maritime world. They were following paths already discovered, tested, lost, and rediscovered by people whose lives belonged to a much older age. When farming begins to spread across the ancient world, it does not arrive at the shoreline as a stranger. The first agricultural communities inherit seas already crossed by generations of hunters, fishers, gatherers, quarry workers, and explorers. They inherit landing places whose value has been tested, islands whose freshwater sources are remembered currents, whose seasonal behavior is known, and routes preserved through stories rather than charts. Agriculture changes the scale and purpose of maritime movement, but it does not create the idea of crossing water. The sea lanes used by early farmers rest upon a much older foundation. This is especially clear in the Eastern Mediterranean. On the mainland, communities begin cultivating cereals, managing animals, and building more permanent settlements. These changes allow populations to grow, but they also produce new vulnerabilities. Fields depend on rainfall, herds require pasture, villages need timber stone and reliable water. When people cross to Cyprus carrying seeds, goats, cattle, pigs, tools, and household possessions, they undertake voyages far more demanding than a brief hunting expedition. Yet the route itself has already been explored by pre-farming visitors. The island is no longer an abstract shape beyond the horizon, it is a known landscape. Transporting livestock reveals how sophisticated these voyages have become. A live animal is unpredictable cargo. It shifts its weight, consumes water panics in rough seas, and can damage a lightly built vessel. Animals must be restrained without injury and separated when necessary. Fodder and drinking water add further weight. Seeds must remain dry. Stone tools, food, timber, and people compete for space. These challenges encourage larger or more stable craft-coordinated crews and carefully timed departures. Maritime knowledge that once supported a handful of travelers now carries entire communities and the biological materials needed to recreate their way of life on another shore. Across the Aegean, farming populations expand among islands already linked by the movement of obsidian. Melos continues to provide volcanic glass, and distribution networks become denser. Settlements appear in places chosen partly for access to sheltered bays, fertile soil, fresh water, and maritime routes. Boats carry stone pottery, food, animals, and people. Islands cease to be occasional destinations and become permanent parts of a connected regional economy. The network grows more visible because farmers leave houses, storage pits, ceramics, and graves, but its deeper ancestry lies in the sparse black flakes left by hunter-gatherers. The same pattern appears in many regions. Later seafaring societies often develop along coastlines where earlier communities already possess fishing skills, boat-building traditions, and knowledge of offshore environments. New technologies improve range and carrying capacity. Sails eventually harness the wind. Planks can be joined into larger hulls. Harbour specialist crews and political authorities organise movement on a scale impossible for small mobile groups. Yet every later development begins with principles learned much earlier. Wood floats fibres, hold structures together. Currents can be anticipated, and land can exist beyond the visible horizon. The disappearance of the Ice Age coast hides the continuity between these worlds. Archaeology often finds the later village more easily than the earlier seasonal camp. Stone foundations remain above water, while temporary shelters vanish beneath drowned shelves. Pottery survives in abundance while baskets and wooden containers decay. Domesticated animal bones can be traced through settlements, while fish caught from an earlier canoe leave only scattered fragments. The record, therefore, creates an illusion of sudden transformation. Seafaring seems to appear alongside farming because farming leaves evidence that is easier to see. What survives in the record suggests a slower accumulation. Before farmers transported herds, hunters may have carried dogs, captured animals, or useful plants between islands. Before permanent villages, seasonal camps taught people where wells and sheltered beaches could be found. Before formal trade, rare stones and ornaments moved through personal exchange. Before navigational specialists experienced coastal travellers remembered how clouds formed above distant mountains. The agricultural maritime world enlarges these practices rather than replacing them. This legacy is not only technological. Voyaging changes how human communities imagine space. A sea can be understood as an edge separating the known world from danger, or as a field of routes connecting distant places. Ice Age sailors helped create the second understanding. An island beyond the horizon could become part of a community's social territory, even if it was visited only once each season. People who lived on different shores could remain linked by marriage exchange, shared ancestry, and remembered journeys. Water divided their camps physically while joining them culturally. The consequences could be destructive as well as creative. Human settlement transformed island ecosystems. Hunting contributed to the decline of vulnerable species in some places. Fire altered vegetation. Introduced animals competed with native wildlife, damaged forests, and changed soils. Farming intensified these effects by bringing larger populations and species selected for human use. Islands that had evolved in isolation for millions of years were reorganized within a few centuries or millennia. The sailors who opened these routes therefore initiated environmental changes whose full scale they could not have foreseen. Their movements also changed humanity itself. Populations separated on islands developed distinctive genetic histories, languages, technologies, and traditions. Some remained connected to neighboring shores. Others became isolated when sea levels rose. Routes were forgotten or vessels ceased to travel. The same water that allowed expansion could later preserve difference. Island communities became laboratories of cultural adaptation, shaped by limited resources. Storms' distance and the constant tension between independence and connection. Many early routes were eventually lost. A quarry might be abandoned when better stone became available. A landing beach could drown or be blocked by sediment. A volcanic eruption might erase a settlement. Climate change could alter winds, currents, forests, and freshwater. Oral knowledge could disappear when a community declined or when the last experienced navigator died. Later sailors sometimes rediscovered islands that humans had visited thousands of years before, unaware that their supposed first arrival repeated an ancient journey. This makes the history of seafaring less like a straight progression and more like a series of advances, interruptions, and recoveries. Knowledge is accumulated, but it is also fragile. A boat-building tradition depends on suitable materials and people who know how to use them. A route survives only while communities continue to remember and travel it. Agriculture expands maritime activity in many places, yet it also obscures the earlier sailors by covering their camps, transforming their landscapes, and becoming the more visible beginning of the story. The deepest legacy of the Ice Age voyages is therefore not a particular vessel or route. It is the proof that human beings learned to cross open water while living in small communities without farming cities, metal, or writing. They did so with materials gathered from forests and wetlands, with directions carried in memory, and with knowledge refined through journeys whose failures left no record. By the time the first farmers loaded seeds and animals into boats, the revolutionary act had already occurred. Someone had stood at the edge of the land, accepted that the horizon concealed rather than ended the world, and pushed away from shore. The earlier sailors leave almost nothing that can be held. No intact hull waits beneath a museum roof. No carved tablet records the names of those who departed the weather they feared, or the island that first appeared through the haze. Their harbours lie beneath modern seas, and the beaches where families watched them leave have been covered by water for thousands of years. What remains is absence shaped like achievement, people living where walking could never have taken them black glass. Far from its volcanic source fires, burning in caves beyond deep channels and human lineages established on the opposite side of the ocean. The sea has hidden the beginnings of this story more effectively than any desert or forest. It has drowned the camps, scattered the tools, and erased the marks of boats pulled across sand. Yet it has also preserved the distances that make the achievement visible. The channels around Flores remain deep. The Kuroshio still moves northward. Crete and Cyprus still rise apart from the mainland. These waters remind us that the crossings were real even when the vessels are gone. Perhaps the first successful crews did not think of themselves as explorers. They may have been searching for bird-stonefish safety, or a place where smoke had been seen beneath a distant cloud. Their world was not divided into prehistory and civilization. It was made of remembered coasts, familiar winds, dangerous seasons, and stories about what waited beyond sight. One journey extended that world. Another made the route known. Generations later, a crossing that had once seemed impossible became something taught to the young. The oldest maritime past survives in this quiet transformation. An island changes from a mystery into a destination, then from a destination into a home. The names of the sailors disappear, but their decision remains inside the geography of human life. Long before fields spread across valleys or stone walls enclose cities, fragile craft were already moving over deep water, carrying small groups beneath immense skies. And somewhere beneath the waves beyond the modern coast, the first landing places still rest in darkness. Currents pass above them. Sediment gathers slowly. The world has changed its outline, but the voyage remains suspended between a vanished shore and an island waiting on the horizon.